So this problem is on page 9 of your note packet, and it's a word problem that involves using your graphing calculator. You first have to input the data into your stat function. Let me see if I can pull this up here on this one. If you go into stat and then edit, hit enter here, you'll need to type in the numbers in the domain and in the range here. So I've got my x's versus my y's that I've typed in already. The x's represent the age of the person, and the y values represent the amount of sleep required for each person, or their age group anyway. So once I have that, it says use the data to find a logarithmic regression. And now you've got to pay attention. This is LNREG, equation to the nearest tenth. So when I go into the stat menu again, and I click over to calculate, notice I don't want LIN regression. That's linear regression. I'm looking for logarithmic regression. So if I scroll down a ways, that's still linear regression. There's the one I want, logarithmic regression, LNREG. And if I hit enter, I see that, and then I have to hit enter again. And it'll come up with my values that I plug into this form here. So it says to round to the nearest tenth, which means 1 decimal place. So it's going to be y equals, my a value is going to be 14.8 plus, and let's see what my b value is. In front of the natural log, it's going to be negative 2.1. Your tenths place is 1 decimal place. So minus 2.1. Let's go minus 2.1 natural log of x. Or a better way to write that is y equals 14.8 minus 2.1 natural log of x. And then what we're going to do, just like we did with the linear equations, we're going to use this equation to answer questions later on. So let me scroll down here a little bit. Using that equation, find the number of hours of sleep required by a 35-year-old. So they're giving me the x value, the 35-year-old, and we want to see what the y value is and round it to the nearest tenth. Well, let's take a look back up at our chart here for just a minute. Oop, a little too high. For a 35-year-old, we would expect our number of hours to be somewhere between 6 and 8 hours, because for a 25-year-old, it's 8 hours. For a 50-year-old, it's only 6 hours. So for ours, we were looking for a 35-year-old. So we're guessing somewhere between 6 to 8 hours. But let's not guess, let's find out. So it's y equals 14.8 minus 2.1 natural log of 35. And then just type that into your calculator directly. Clear this out and do 14.8 minus 2.1 natural log of 35. Okay, so I just type that in. I'm going to close parenthesis and then hit enter. So it comes out to about what we thought it should be, about 7 hours or so. So they wanted to round to the nearest tenth. So we look at the hundredths place to determine whether we have to round up, and in this case we don't. So it's 7.3. And then the unit label on this is going to be number of hours, or 7.3 hours of sleep. Okay. And then the last question, algebraically find the age of the person. So now we're looking for x, that was the age of a person that requires 12 hours of sleep. So we go back up to our equation that we came here with, this one, and we're going to plug in the y is 12 now. But before we do that, let's take a look at our chart again. So we're looking for someone that takes 12 hours of sleep or requires 12 hours of sleep. That's going to be someone between the ages of 2 and 6, right? Because a 2-year-old needs 13 hours, a 6-year-old needs 11 hours. So it's somebody between the ages of 2 and 6 that's going to require 12 hours, just to kind of give us an idea of what our answer should look like. So I'm going to plug in the 12 for y equals 14.8 minus 2.1 natural log of x. Now my goal is to get this by itself first and then go ahead and undo that. Now keep in mind you can't subtract 14.8 minus 2.1 because the 2.1 is hooked to the natural log of x. But I can move the 14.8 to the other side of the equation by subtracting it off to both sides. This is what we were doing in the You Try It questions earlier, solving for a log function. Get everybody away from it and then rewrite it as an exponent. So this is going to be negative 2.8 equals, bring down the negative 2.1 times natural log of x. To undo multiplication, we divide both sides by negative 2.1. I'm going to get natural log of x equals, a negative divided by negative is going to be positive. You can go ahead and type in the 2.8 divide by 2.1. So I get 1.333 all the way across. Now I'm not going to round this number. I'm going to do this. Just call it 1.33 with a bar over it. That indicates that the 3's repeat. Now I want to solve for x. So I want to undo a logarithm. Exponentials undo logarithms, so I have to figure out what's the base of the logarithm. That becomes the base of my exponent. So the base of my logarithm is e. The base of my exponent is also going to be e to the 1.33, and that's going to be what my x is. So using my calculator, I already have this number completely on here, so what I'm going to do is just do second natural log to get the e, and then instead of typing 1.33333 all the way across, I can do second, and then if I come down here to the negate key where it says answer, it's going to paste the answer from above and put it right there so that I don't have to type in 1.33333 all the way across, and then just hit enter. So about 3 point, and then if I round to the nearest tenth, I have to look to the decimal place over, 1 over from it, or the hundredths place, and see that I have to round up. So that's going to be about 3.8. Keep in mind what you found the age of the person, so 3.8 years old, which is kind of what you figured when you look back up at your chart. Somebody that needs about 12 hours of sleep, we said, was going to have to be someone between the ages of 2 and the ages of 6. So you came up with about 3.8 years old. That's about right.